Today we are going to learn about lesson chapter solutions. In this chapter we are going to learn six main topics, which are the types of solutions and concentration expressions of solutions, solubility of solutions, vapor pressure of solution, ideal and non-ideal solutions, colligative properties of solutions. So first main topic is types of solution. Solutions are categorized into three types: gaseous solution, liquid solution, and solid solutions. Gaseous solution are further categorized into gaseous and gas, liquid and gas, and solid and gas. For gas and gas, we have oxygen and N2 as a mixture, and for liquid gas have that is chloroform and nitrogen, and solid gas we have camphor and nitrogen as an example. Now for liquid solutions, gas and liquid, we have oxygen and water. For liquid we have ethanol, which is alcohol and water. Solid liquid we have glucose and water. Now last is solid solutions. Gas and solid will give hydrogen, palladium. Solid as amalgam and sodium. Solid we have copper and gold.
Actually, sodium, any metal in combination with mercury can be called the respective amalgams.
Yes, sir.
For example, sodium is dissolved in mercury. Sodium is metal, mercury
okay,
is also metal. So it is a metal solution. So
Yes,
it's
sir.
an amalgam.
Yes,
Okay.
sir.
Actually, this is a gas, liquid, solid. You have classified the types
Yes, sir.
based on the solvent, is it not?
Yes,
Because
sir.
solvent is the major portion.
Yes, sir.
Okay, so based on that, you are classified into gas, liquid, solid. So it means gas is in the first case, gas is the major portion, that
Yes,
is
sir.
solvent. And that
Yes,
is
sir.
why GG, LG, SG. That is gas, liquid
Gas and solid gas.
And what about the second one? Liquid is the
Major.
solvent portion, major portion.
Yes, sir.
Usually, how to represent the major portion? By number 2.
Yes,
1.
sir.
1.
Yes, sir.
So solution consists of two parts, solute and
And
solvent.
solvent.
Can you define solute? Solute is the minor portion.
Minor portion of solution. Yes.
Okay. Solvent is the major
Major portion
portion.
of the
So
solution.
we give importance to solvent means 1.
Yes.
Solute means 2.
Yes.
W1 means weight of solvent.
Solvent. Yes.
W2 means,
Weight of solute.
so that is the representation you are used here.
Yes, sir.
Right, proceed.
Now the second main topic is concentration terms. There are totally 7 concentration terms. First is percentage term. We are going to talk about percentage. There are 3 types of percentage term, which is classified into weight by weight percentage, weight by volume percentage, and volume by volume percentage. First is weight by weight percentage, which is shown as weight of solute by total weight into 100.
Total weight of the solution.
Yes, sir. Then total weight is represented by W1 plus W2, which is solvent plus solute. Next is weight by volume, which is weight of solute by volume of solution into 100. And volume by volume is volume of solute by volume of solution into 100. Next is molarity is represented by capital M, which is number of moles in solute divided by volume of solution. In volume of solution is represented in milliliters.
Liter.
Okay, in liters.
In the previous case, that is given in ml.
ml. Yes, sir. Then small m is represented as molality, which is given as number of moles of solute by weight of solvent in kg.
Usually in case of solution, dilute solution, the weight of solute is negligible. That is why we take as solvent.
Yes, sir.
But generally it is weight of the solution only.
Yes, sir. Now next is mole fraction. Mole fraction is represented by 2 parts. We are taking two parts, as one is solvent and one is solute. So if you take solute, it is number of moles of solute by total number of moles, which is number of moles of solute and number of moles of solvent. If we take mole fraction of solvent, we get number of moles of solvent by total number of moles in a solution. Next, third main topic is solubility of solution, which is 3 three topics, which is unsaturated solution, and it has effect of temperature, effect of pressure. And then with this, these are in solid and liquid state. And next is gas and liquid. Gas and liquid tells us that solubility of gas and liquid is directly proportional to the partial pressure of the gas. And next point is mole fraction of gas is directly proportional to partial pressure of the gas. And last is partial pressure is equal to kh into mole fraction of gas, where kh represents Henry's constant and xg, that is chi g, represents mole fraction of gas. Next, fourth main topic is vapor pressure. Vapor pressure has two main formulas, which is total partial pressure, represented by
Partial pressure of solvent
partial pressure of solvent
plus
plus partial pressure of
solute.
solute minus of partial pressure of solvent into mole fraction of solute. Next is, this is general
Some
formula.
authors they represent this by A and B also.
Yes. Okay,
Because
sir.
it is a binary mixer, two component mixer, either of them may be solvent or solute. So, for a general representation, you can take like this. Otherwise, you are, see, after all, the smaller portion is represented as 2.
Yes, sir.
Major portion is represented as 1. That's all. Suppose if it is alcohol water system, alcohol is very less means that is taken as solute. 2. Solvent is water. Suppose water is less, alcohol is more, means alcohol is the solvent,
Yes.
water is the solute.
Solute.
So in that case, water is taken as 2. Solvent is alcohol, that is taken as 1.
So then what about 50% and 50%?
50, and that is why need not be. See, that is a 1 and 2 means that is equal. We cannot go to 1:1. These are all simple representation for our better understanding.
Yes, sir. And the second is a general formula. We are going to calculate partial pressure of solvent and solute, where I represents 1 and 2. Where 1 is a major part of solution and 2 is minor part of solution, as we discussed. So this formula tells us P of I is equal to yi into pt. If P is 1, we are calculating the partial pressure of solvent. If I is 2, we are calculating the partial pressure of solute.
What is that yi?
Uh,
Actually, that is chi I. It is not y, chi.
chi I.
That is mole fraction, is it not?
Yes, sir. Chi I. Now, fifth major topic is ideal and non-ideal solutions. First is ideal solutions. We are taking the enthalpy of mixture is 0 and volume of mixture is 0. This, if this satisfies the given solution, it is called an ideal solution. And non-ideal, we are categorized into positive and negative deviation. And in this graph, first is positive deviation and second is negative deviation. This point is where chi of solvent is equal to 1 and chi of solute equal to 0. And the starting point represents chi of solvent equal to 0 and chi of solvent equal to 1. And the curve going upwards represents the positive deviation. This is called partial
Mixer.
is
Partial vapor, vapor pressure.
vapor
That
pressure.
the mixer.
Mixture of vapor
The
pressure.
lower one represents the individual
Yes, sir.
vapor pressure.
And this shows a negative.
And the
deviation.
dotted line, the ideal behavior.
Yes, sir. Now, last and main topics is the colligative properties. In colligative properties, there are 4 main subtopics. First is RLVP, relative lowering of vapor pressure. This is represented as P1 naught minus P1
Not represents what?
pure.
Pure.
So pure solvent minus solvent by pure solvent is equal to,
That is vapor pressure of pure solvent.
yes, sir,
Minus vapor pressure of solvent.
by vapor pressure.
That
of
is
pure
not solvent, solution.
solution. Will give a weight of solute into mass of solute by mass of solvent into weight of solute. This represents the relative lowering of vapor pressure. Next is elevation and boiling point. which is further represented as mass of solute is 10 power 3, which we can also write 1000. So 10 power 3 into weight of solute into kV. KV is
Ebullioscopic constant
yes
or
sir,
molar elevation constant.
molar elevation constant by delta TB into weight of
W1
solvent.
solvent.
And
What is delta TB? Elevation of boiling point.
elevation of boiling point. Yes sir. Now next is depression and freezing point, KB, which is azeotropic. No,
Which one?
KB,
KB. KB is a cryoscopic constant.
triascopic constant.
KF, what is that? FP, what is that?
Depression and
Freezing
point.
point. Freezing point. Freezing point should be represented as KF,
KF.
cryoscopic constant, or molar depression constant.
Molar. Yes sir.
So, depression, freezing point depression, that is the drop in the freezing point. For example, when you take ice, when you add sodium chloride, it drops to -4, -7, like that. Okay, so that is a depression of freezing point. Okay.
Which is represented R into M, where R is gas constant and M is total mass, into TB square by 10 power 3 into enthalpy of vapor pressure. And fourth and last topic is osmotic pressure, which is represented as M2, which is weight mass of solute. Mass of solute equal to weight of solute into RT, where R is gas constant, T is temperature, and pi into V. V is volume.
Now, can you show me, clarify that freezing point? Get me the book. KF and KB. What you have mentioned about the KB? Where is it? Where is KB?
KB.
I think you are not included that one.
Yes, sir.
Okay, you can include. You can give both. KF nearby KP. You can put a KP also. You are given KF but not included KB. So include that one also.
Yes, sir.
So KF represents the cryoscopic constant, which is nothing but molar depression constant. Okay.
Yes.
And KB
represents the
okay
elevation.
ebullioscopic constant or elevation molar
constant.
elevation. Molar.
Molar.
LAL. Okay.
Yes.
You can include that one also.
Then KB is represented as R gas constant into total mass into TB.
That is not total mass. Mass of the molar mass.
Molar mass.
Capital M represents molar mass of the solute.
Okay, sir. TB square by 10 power 3 into vapor pressure of enthalpy of vapor pressure. In freezing, in KF, this is enthalpy of fusion.
Fusion.
Not enthalpy of vapor pressure.
What is enthalpy?
Heat.
Heat content.
Yes.
That is any heat change taking place at the constant pressure can be called
as enthalpy.
Okay, enthalpy. Internal energy means it is a function of temperature and volume.
Yes, sir.
Enthalpy is the function of temperature and pressure.
Yes.
Okay, so that makes the difference. So when you calculate any heat changes at constant pressure, it is called enthalpy. When you calculate at constant volume, it is internal energy. So we are more focused on enthalpy here, right? Yes. And I think you have presented very nicely. I would like to ask one important question in this. Dilute solutions, that is solution, in this case solutions. Okay, so what is colligative property? What are colligative properties?
What is colligative properties?
What are colligative property means you can list out the properties like relative lowering of vapor pressure, then elevation of boiling point, depression of freezing point, increase of osmotic pressure. That's good. But what about the definition of colligative property? Shall I help you?
Yes, sir.
Right. Colligative property, actually, it is the change in the physical properties
Okay.
because of the presence of the amount of solute. It depends on the amount of solute. For example, the boiling point of water is, that is pure water, is 100 degrees Celsius. Suppose if it contains any salts, it means it is not pure. So definitely its boiling point will not be 100 degree. Instead, it will be 100.1, 100.3, like that. There will be slight elevation, slight
Yes.
increase. Okay, when you increase the amount of solute, it further increases. Do you understand?
Yes,
It
sir.
means there is a change of physical property that depends on the amount of the solute present in the solution.
Yes.
That's all. That is called colligative property.
Yes, sir.
And that is why, based on the amount of solute, these properties vary. Are you able to follow? In
Yes,
all
sir.
these cases, you could have noticed there will be some molar mass.
Yes, sir.
M2. So, with the help of these colligative property studies, we can determine the molecular mass
Yes, sir.
of the solute.
Yeah.
Otherwise, it would be very difficult to identify a molecule from a compound, and weighing and taking a suitable balance for weighing such a very, very microparticle is very, very difficult.
Yes.
So, in that case, that is with the help of the experimental parameters, we are able to find out hypothetically what the molar mass
Yes,
of the
sir.
solute. Okay. So that is the greatest advantage of this colligative property.
Yes, sir.
Okay. Right.
So, in nutshell, the change in physical properties is known as colligative properties.
Change of physical properties that depend on the amount of solute present in the system. That is called colligative property.
Change in physical
Property.
properties.
That will be a change in physical property, and that change depends on the amount of solute present in the solution system.
Yes, sir.
Whether it is a binary solution or trinary solution, whatever it may be. Okay, so it all depends on the amount of solute present in the system.
Yes, sir.
Okay, right. Good, very good.